Artificial intelligence, machine learning. You've heard these words thrown around constantly, right? Sometimes even in the same sense. But are they actually the same thing? Well, the short answer is no. And over the next few minutes, we're going to break down exactly what makes them different and why it really matters. So here's our game plan. First, we'll dive right into the confusion and figure out why these terms get so mixed up. Then, we're going to pop the hood and see how a machine actually learns. Once we get that, we'll zoom out for the big picture, put them side by side for a clear comparison, see them out in the wild, and finally, we'll ask the big question, what's next?
All right, let's start right there, with the problem itself. Why is there so much confusion in the first place?
This is the core question, isn't it? And hey, if you've ever felt a little fuzzy on the answer, you are definitely not alone. In fact, it's so common that even the big players in tech have to address it.
I mean, look at this quote from Google Cloud. They're basically saying, hey, we get it, it's confusing. And it is totally understandable, because they aren't enemies or total opposites. They're actually deeply connected. As we're about to see, one is a really powerful way of making the other one happen.
Okay, so to really get a handle on the difference, just reading definitions isn't going to cut it. We need to see the process. So let's pull back the curtain and look at the engine that drives so much of modern AI, machine learning. You know, what's so cool about this is how simple the core idea really is. Step 1, you just gather up your data. Let's say how many stores a company has versus its revenue. Step 2, you try to find a basic pattern. Maybe a simple straight line seems to fit. Now, step 3, this is where the magic happens. We call it training. The machine just adjusts that line thousands, maybe millions of times, nudging it a tiny bit here, a tiny bit there, until it gets as close as possible to all those data points. That final, perfected line, that's your model. And now you can use it to make predictions. That whole process, that cycle of learning from data over and over again, is the very heart of machine learning.
Okay, so that's the how. That's the engine. Now let's zoom out and see where this powerful engine actually fits into the grand scheme of things. And this is the perfect time to ask, right? If that whole process of finding patterns in data is machine learning, then what on earth is artificial intelligence?
And here it is. This is the crucial distinction. Artificial intelligence isn't one specific method. It's the entire field. It's this huge, ambitious quest to build machines that can act like humans, that can reason, learn, and solve problems. You could say AI is the what we're trying to build, and machine learning is one of the most powerful hows we have to get there. This slide just makes it crystal clear. The best way to think about it is that AI is this giant umbrella. And underneath it, you've got machine learning, that pattern-finding engine we just talked about. But you also have all these other amazing fields, like robotics, which is all about giving machines bodies to interact with the world, or natural language processing, which is what helps them understand what we're saying. They're all different approaches to the same big goal. So machine learning isn't separate from AI. It's one of the most vital tools inside the AI toolbox.
So now that we understand that relationship, the umbrella and the tool, let's put them right next to each other to make the key differences pop.
Looking at it this way, it just clicks, doesn't it? The goal of AI is huge. Build a system that can act like a person. The goal of ML is way more focused. Get really good at one thing by learning from data. The scope reflects that too. AI is this vast, wide-open field, while ML is all about spotting patterns. It's like AI is the whole spaceship, and machine learning is that super powerful engine that lets it learn how to navigate the stars.
Okay, that's enough theory. But where do you actually run into this stuff? The answer, and you might be surprised, is everywhere. It's already woven into your daily life.
Just think about it for a second. The big AI system is Siri understanding your question. The machine learning is the specific model it uses to recognize your words. The AI is Netflix wanting to give you the perfect movie recommendation. The ML is the algorithm that's learned your taste from every single thing you've ever watched. See the pattern? In all these cases, a specific machine learning model is the powerhouse driving a bigger AI application.
And it's so much bigger than just our personal gadgets. In healthcare, there are machine learning models being trained right now to spot signs of disease in medical images, sometimes better than a human can. In finance, they learn your normal spending habits so they can instantly flag a transaction that looks suspicious. These are all incredibly specialized tasks, where learning from massive amounts of data is a total game changer.
So we know the difference, and we've seen it in action. But where is all this technology actually headed? What's the roadmap look like for the future of AI?
Okay, so right now we are living completely in the age of what's called artificial narrow intelligence, or ANI. Every single AI you have ever interacted with, Siri, ChatGPT, you name it, is a narrow AI. It might seem like a genius, but it's really a one-trick pony. It's hyper-specialized for its one single job. The next huge leap, the thing everyone's racing towards, is artificial general intelligence, AGI. That's an AI with human-like flexibility and learning ability. And then, way out there, is the theoretical idea of artificial superintelligence, or ASI.
And that brings us full circle. We started with a simple line on a graph, and we've ended up at the very future of intelligence itself. Every AI we have today is a master of one specific task. So the question to leave you with is this: what does our world actually look like when a single system can learn and reason about, well, anything?